Hi guys, so welcome to the second video on differentiation. In this video we shall continue with basic questions with an emphasis on questions that require that we use the GDC. These are the four questions that we shall tackle, and I shall begin question 1 shortly. So the first question in this video came in paper 1, May 2014, time zone 2, question number 15. Kindly pause the video, attempt to solve, and my answer shall follow through shortly. So we are given the function f of x equals 2x cubed minus 5x plus 4 over x plus 3. And in question A, we are required to write down the derivative function. Like I did in the previous video, I shall first attempt to simplify or to rewrite one of the terms to make it easier to differentiate. In particular, I am talking about this third term right there. We said that if x ever appears in the denominator raised to any power, whether x or x squared or x cubed, I take it up to the numerator and I write the power in negative. So here I had 4 over x to the power of 1. It became 4 times x to the power of negative 1. So this is the only change that I made to go from the black equation to the blue one. And I have not differentiated yet. Hence, I have f of x here in the question and I have f of x here in the step, because this is still the actual function, f of x. Now to obtain f dash of x, which is the derivative function, I shall differentiate, and we already tried similar problems before. I shall begin with the first term, 2x to the power of 3. I shall multiply by the old power, so 3 times the number outside, which is 2, gives me 6. Next, I shall reduce the power by 1, so I get x squared. For the second term, negative 5x simply becomes negative 5, because negative 5x is like negative 5x to the power of 1. So x to the power of 1 becomes x to the power of 0 and vanishes. Now for the third term, I have 4x to the power of negative 1. Again, I multiply by the old power to get negative 4, and I reduce the power by 1, so it becomes x to the power of negative 2. As for the final term, I only have a constant, I do not have a variable here, so the constant vanishes entirely during differentiation. Hence, my derivative expression and the answer to question A is f dash of x equals 6x squared minus 5 minus 4x to the power of negative 2. Now in question B, I'm required to use the graphic display calculator to find the coordinates of the local minimum point of f of x in the given domain. So let's see how to do that. So for f of x equals 2x cubed minus 5x plus 4 over x plus 3, I am required to find the coordinates of the local minimum point. So first I shall type this function on the GDC. I shall do that by accessing y equals, writing down the equation, and clicking on the trace button. So this is the graph of my function, and I'm required to find the local minimum point, which is right there. So in order to do that, I shall press on second, trace, and I shall go to the third option, which is minimum, and I shall press enter. I'm asked to provide a left bound, so I want any point to the left of my minimum. So I'll drag the cursor using the right button up to a point that is just on the left of my minimum point, and I shall press enter. Next, I'm required to find a right bound, so I shall drag the cursor to the right hand side of my minimum point, and I shall press enter. Finally, I'm asked to provide a guess for where the minimum point is, so I shall again drag the cursor roughly to where I believe the minimum point is, and I shall press enter. So as you can see, the calculator tells me that the x coordinate of my minimum point is 1.15, and this is the value that I've written down. So two important points to make. This point that we have found right there is not the lowest point in the entire graph, because as you can see, this region of the graph is all below this point. This is why we call this a local minimum, not an absolute minimum. It's not the lowest point in the entire graph, but the local minimum is a turning point where in a part of the graph, which is this part, this is the lowest point. This is why it is a local minimum and not an absolute minimum. So I am required to find the x coordinate and the y coordinate of the local minimum. So I've also written the y value right there as well. And you've actually found what is required. So take a minute to check the GDC settings out if you want to copy any of this down. So I got the equation from y equals, and I've written it down. Then I pressed on trace to get the graph. Then I pressed on second, trace to get the operations, and I chose the minimum value. This is how you use the GDC. So this concludes our first question. Take a minute to write this down if you will, and I shall begin question 2 shortly. So the second question in this video came in paper 1, May 2016, time zone 2, question 15. Kindly take a minute, pause the video, attempt to solve, and the answer shall follow through shortly. So for question A, I'm required to find f dash of x, where f of x equals x cubed minus 3x squared plus 2x plus 2. So this is a very simple differentiation problem. X cubed becomes 3x squared, minus 3x squared becomes negative 6x, 2x becomes 2, and this constant right there vanishes during differentiation. Hence I get the expression in green. For question B, I'm told that there are 2 points at which the gradient of the graph of f is 11. So we said in the previous video that the gradient of the graph of f is found by getting f dash. So if the gradient is 11, then f dash of x equals 11. And we already found f dash to be this green expression right there. So I shall simply equate it to 11 and solve to find the values of x that shall give me the x coordinates of the required points. In order to solve this blue equation, I can either do it manually or by the GDC. Using the GDC requires that I first set the equation to 0, as in the gold equation right there. I simply did this by taking this 11 to the left hand side with a negative. So 2 minus 11 gives me negative 9. So I shall use this gold equation, I shall write it down on my calculator, graph it, and find the points where the graph cuts the x-axis, or in other words, find the zeros of this gold equation. Let's see how to do that. So first I shall click on y equals, and I shall write down my expression, which I've already done, 3x squared minus 6x minus 9. Next I shall click on trace. There is my function. In order to find the values of x where this function is 0, I shall click on second, trace, 0. Now I know that roughly the first 0 is somewhere right there, right? So in order to find the exact value, I need to give the calculator a left bound and a right bound. So the left bound is any point to the left of my point. So there. The right bound is any point to the right of my point. So somewhere here. Finally, I need to give the calculator a guess as to where my point is, and I shall guess that it is right there. So I am told by the calculator that the first 0 occurs at x equals negative 1. Hence, this is my answer, one of my answers. I shall repeat the process for the second 0. So again, second, trace, 0. Now I want to do the same thing for the other point. So again, the left bound is any point to the left of my point. So there. The right bound is any point to the right hand side of my point. So there. And finally, the guess is where I believe the point is. And the calculator tells me that the second value of x is 3, which is what I've also written down here for my answer. So this concludes our second question. Take a minute to write this down if you will, and I shall begin question number 3 shortly. So the third question that we shall tackle in this video came in paper 1 November 2016, question 14. Kindly take a minute to pause the video, attempt to solve, and the answer shall follow through shortly. So I'm given this equation, also written here in black, y equals half x to the power of 4 minus 3 over 2x squared plus 7. And in question A, I'm required to find dy over dx, or what we call y dash, which is the derivative function of y. So I shall simply differentiate this black equation. Half x to the power of 4 gives me 2x to the power of 3. This was obtained by multiplying the 4 by half to get this 2 right there. Then reducing the 4 by 1 to get the new power, which is 3. Same thing with the second term. I have negative 3 over 2x squared, so I shall multiply the old power by the number beside the x. 3 over 2 times 2 gives me 3, so there is my 3. And the x squared becomes x power 1, or just x, because I reduced the power by 1. Finally, the third term, which is a constant, vanishes entirely from my expression. Hence I obtain the green expression, which is the solution for question A. Now for question B, I'm told that the gradient of the tangent to the curve at point P is -10. Like the previous question, we deduce that since the gradient is -10, hence f dash of x equals -10 or y dash equals -10, and I already have an expression for y dash, so I write it and equate it to -10, and I need to solve this equation. And this equation is difficult to do manually, so you're going to have to use the GDC in this question, unlike the previous one where you could have actually done some factorization and solved manually. But the same procedure applies as we said in the previous question. In order to solve the blue equation using the GDC, I shall first have to equate it to 0. I need something equals 0. So I'll get rid of this -10 by taking it to the other side. However, I shall change the sign to positive. So the purple equation is just the same as the blue equation. It is equivalent to the blue equation, but it is in a format that I can use to solve on the GDC. So I shall just write this equation down on the GDC now. So I clicked on y equals to get this screen, and I've written down my equation. Now I'm going to click on trace. Now in this question I'm required to find the coordinates of the point where the gradient is -10, and I shall do that by finding the 0 of this equation. So I'm going to click on second, trace, find the 0, like the last question exactly. I'm going to give the calculator a left bound, so I'm going to go to the left of the point that I'm looking for and click on enter. Then I'm going to go to the right hand side to give the calculator a right bound. Finally, I'm going to give the calculator a guess, and the calculator tells me that the 0 of this equation lies at x equals -2. Hence, the x coordinate is -2. However, do not be confused taking this value as the y coordinate of point P. Watch out, this is not y, this is y dash, right? So this curve is the curve of y dash, the derivative function. So in order to get the y coordinate of P, I'm going to have to refer back to my original function. So this is something different from the y value given by the calculator. I'm only interested in the x value, so watch out. So in order to find the y value of point P, I shall simply plug x equals -2 into the original equation to find y. So instead of every x, I'm going to plug -2. And this is what I've done in the dark blue equation right there. You can evaluate this on the GDC easily, and it shall give you a 9. Hence, the coordinates of P are -2, which is the x, and 9, which is the y. Now, take a minute to copy this down, if you will. I shall begin the fourth and final question of this video shortly. So the fourth question in this video came in paper 1, November 2017, question 14. Kindly take a minute, pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, I am given f of x equals 4x cubed plus 3 over x squared minus 3, also written in black right there. And I'm asked to find the derivative of f, or to differentiate the function. Like we did in previous questions and previous videos, whenever I see and x in the denominator, I first raise it to the numerator and express it in a negative exponent to facilitate the differentiation. So f of x is still f of x in the green equation. I have not differentiated yet. Now to differentiate, I shall first target the first term. 3 times 4 gives me 12, and the 3 is reduced by 1. For the second term, negative 2 times 3 gives me negative 6, and the power is reduced by 1. And the third term vanishes entirely because it's a constant. Hence, this dark blue expression is my answer to question A, and it is the derivative function of x. For question B, I'm required to find the point on the graph of f at which the gradient of the tangent is equal to 6. Just bear in mind that the gradient, or the gradient of the curve, or the gradient of the tangent to the curve, all mean the same thing. They just mean that I need to get f dash. So the gradient is equal to 6, hence f dash of x equals 6, and I substitute the dark blue expression instead of f dash and equate it to 6. I shall use the GDC to solve this equation as I've done previously, and we said that you have to set it to 0. So I shall take this 6 to the left hand side, but I shall turn it into a negative 6, and I shall write this blue equation on my GDC and attempt to find the zeros. So I've written down the blue equation on the calculator. 12x squared minus 6 over x cubed minus 6. I shall then click on trace. I want to find the zero of this graph, or the point where the graph cuts the x-axis. So I shall click on second, trace, find the zero, give the function a left bound. So the point that I want is roughly there, so a left point is somewhere here. Now a right point is somewhere here, and my guess is somewhere here. And the calculator tells me that there is a 0 at x equals 1. And like I said in the previous question, do not take the y value because this is a sketch of y dash, not of y. I'm only going to take the x value and I shall compute the y value manually. So the x value as obtained by the GDC is 1. In order to get the y value of the point, I shall plug 1 into the original equation, and this is what I did in the gold equation right there. And by computing this, I got the y value to be 4. Hence, the point has coordinates 1 and 4. So this concludes the fourth and final question in this video. Take a minute, pause the video to copy this down if you will. I hope you have found this video useful.